Actually, I'm half Venezuelan and half Italian, but this presentation is going to be in English anyway because I'm too lazy and I didn't translate it, honestly. But feel free, by all means, feel free to ask questions in Spanish. It's totally fine. I can translate them for you if it's going to make it easier for you to actually ask the questions. So the presentation is going to be inheriting code, and I don't mean classes. And one of the reasons I picked the title is because most of the time when we talk about inheriting code, the first thing that we think about is object-oriented programming, and we have a bunch of classes, and we are like subclassing from things and like extending everything. But now we're going to talk about getting code that is not yours. There are different scenarios where you just join a company, join like an open source community or something like that, and you want to jump into a project and basically inherit it from someone, like learn the code base and be able to make contributions to it in a way that is meaningful and useful. So that's what we're going to be talking about today. The slides are already uploaded, pretty much because I'm on top of my shit. So I already uploaded them before I was here. If you want to follow the link, it's fine. That is me, in case it wasn't obvious. Again, I'm half Venezuelan, but my name is fully Italian. So it doesn't have anything to do with Venezuela, but that is my Twitter handler. If you are into this thing that I think is going to be super famous called Twitter, like you can follow me and just like provide feedback. I love feedback. If you like the presentation, tell me about it. I would love to hear your opinions. If there's anything that you think is missing in the presentation, also tell me about it. If you don't like the presentation, that is not my Twitter handler, and I was never here. But jokes apart, like, yeah, by all means, tell me. I really love feedback, and this is a topic that we all go through at some point in our career, because very few of us get the luxury, or will ever get the luxury to actually, start your own company and start from scratch, and the code base is always yours. Like, you're always going to be adopting someone else's code at some point in your career. So I'm pretty sure you all have opinions on this thing. And again, like, why is the presentation in English if I speak Spanish? Too lazy. Again, half Italian. That is the lazy part of me. So I'm not going to translate it for you. All right, inherited stuff from someone that hates you. So why from someone that hates you? It's because someone that hates you will create the worst case scenario for you when you have to inherit code. The best case scenario is that you inherit code from someone and the project is just flowers and rainbows and it all smells good. But the real world shows that, or teaches us that that's not the case most of the time. So we're gonna kind of like try to go through the worst case scenario. The worst case scenario, we're gonna evaluate it in a bit. And so this is the worst case scenario. Then these are the things that I kind of came up with that are worth kind of like mentioning and what would make a project not good or kind of like what would define this worst case scenario that we are talking about. So the first one is you pick up this project and the project has no documentation whatsoever. So there's no way for users or anyone that is not part of the project to actually understand and know how the project is supposed to be used except by running it or just like talking to someone that actually knows how to use it. There are no tests, so you don't know if the thing works actually. Like you can see it running, but who knows, right? It's supposed to do something. It's kind of doing the thing that it says that it's supposed to do, but we don't know if it's actually truthful to what the goal of the project is. The code is written poorly. Well, this is very subjective, honestly. But like I figured I would put it here because we're developers and we all like to judge someone else's code. So the code is written poorly. And to our eyes, everyone else's code is shit. So we're gonna, but again, it's super subjective. And like you have to understand also that something that is like today is written poorly, it doesn't necessarily mean that it was written poorly when it was written, right? Like languages evolve, you have new syntaxes, things change, languages decide to break backwards compatibility and that kind of things, and then you end up with code that is not good anymore. The use cases are unclear. This is probably one of the points that it's very subtle in every project, because when you see this project, like mostly like if you go to GitHub and you see this project, you see on the README and it has like the main goal. But the main goal is like, we want to do this X and Y and Z. But the actual use cases and what it is meant for in the long run or how it is supposed to evolve is very unclear. So you don't really know what the future of this project is going to look like in 10 years from now, or what the maintainer hopes it's going to look like. And deadlines are around the corner. Like if you join a company and like, especially if you're a consultant, you join this company and they of course, like as soon as they hire you, you have to do everything for tomorrow, basically. And everything has to be done even before you actually understand what the project is about. So again, worst case scenario, you're picking up this project. How do you do it? What process you can go through to actually be able to not kill yourself at the end of the day? So we're going to build a process. We're going to go step by step. And the process is going to be painful because we're not going to write any code for a long time until we actually have to write code. So the first step is understand the what and the how without judging the why. And that is a really hard part. So the what. What is it that you have to understand from the project to actually be able to start contributing to it and doing stuff? The first thing is you have to understand the use cases. Yeah, who is supposed to be using this? What is supposed to be used for? It's very common for projects to be created for a very specific thing, and then with time they evolve and they end up doing something completely different. Or it's also very common that you write a project to do something very specific, and then your users find out that they can also use your project for something completely different, and they end up doing that. Now, you might not have thought about developing the project to actually surface that use case as well, but that has become a use case of your project, and you have to decide whether that is something that you want to support or that is something that you want to advise your users against. What is adoption? You want to know how many users you have, how many people are using the project. And this is like knowing what adoption the project has, it helps when it comes to deciding what kind of changes you want to make to the project. If you want to make a change and the change is a breaking change, if you know how many users and what the adoption of your project is, you at least know how many users are going to be impacted by that change, right? And it doesn't mean that the more users you have, the fewer breaking changes you should do. Like remember, like even one user, like it's not fun to break anyone's compatibility and break anyone's environments. So even if you have one user, you have to take care of that. There are a bunch of seats over here if you guys want to sit. Feel free to come around. So you got to understand what adoption is just to know what impact it's going to have every change that you make. What is the plant work? Is there any roadmap? Is anyone thinking about the future of this project? Like whether it is an open source project or it is a project that like a legacy code that you are inheriting, like is there any plan for it? Is there any PM behind it? Are there any customers providing feedback and telling us or telling the project maintainers where the project should go? And what has been done already? You know, you have this roadmap and you have all these goals and things that you want to do, and you have to understand which of these things have been implemented already and what things are left to do still, right? Because like in most of the cases, the things that are still to be implemented are the ones that you're probably going to take on and work on yourself. And then you have to understand how things were done. And by how things were done, you got to understand like the architecture, you got to understand the code, you got to understand what like kind of decisions were made, why those HTTP requests are done, why like how the interaction with the database is, how the entire like data model is interacting with it. Like I'm making up like random cases, but you got to understand how things were done, because the way like when you understand how things were done, you can also make better plans for the future. You can also try to comply to the same guidelines and the same way that things are done in your project. And that includes like, how the software was written. And then you gotta understand the why. The why is written this way. Why there are no tests, for instance. If you come into a project and the project has no tests, right? Is it because the maintainer is like just dislike tests in general? Or is it because the person, the human that wrote this software was put in so much pressure that this human just didn't have time to actually write the test. So they were like, you got to release it tomorrow. I don't care about tests. Like, just make the thing work, put it in production. And the guy is like, well, I guess I have to do it. But, the price to pay for that is that I'm not going to be writing tests for this shit. And why is the documentation missing? Like, is it like, these subtle things that they're related to the software that you're going to adopt, they're related to the software that you're going to inherit, but they don't necessarily speak bad about the maintainer of the software. It can also speak bad about the company itself. For instance, if documentation is missing, why is the documentation missing? Do we have a different team that is taking care of the documentation? Like, do we have other people, other humans that I'll be talking to actually write the documentation? Or is missing because like just the company doesn't give an F about the documentation and they don't want to have a documentation here? Because, I don't know, many times like, people write software and they're just like, we're the only ones using it, or we just care about our use case, and the fact that other people are using it is not a problem to us, so we don't really care about whether they can understand or not how to use the software. So there are many cases like that. And based on the answer to some of these questions, you might want to take the job and the software or not, and just walk away and be happy. And of course, this thing failed on me. All right, that's it. Nope. Computers. All right, there you go. So a mature developer, and I was very careful in not using senior or like super principals or like distinguished and whatever crap people come up with these days. But it is important to understand that one thing that differentiates a mature developer from someone that is just like still, like in my opinion, just like playing around with opinions, honestly, because we all like to have opinions about every software out there. But like a good difference is that a mature developer tries to understand, like seeks the why, like tries to understand the why before, judging the how and what things were done. Because when you understand the why, when you understand why there's no documentation, when you understand why there's no tests for the project, then you know how to fix it, or at least have an idea how to fix it, or at least you know why things were done that way, and then you can decide whether you want to walk away or not, right? So it's important to understand why things were done the way they were done before you judge how they were done. Now, if the answer is there are no tests because the developer just like doesn't care about tests, then feel free to judge him. All right. So step number 2, we haven't written any code yet. So step number 2 is that you have to familiarize yourself with the environment, the code base, and eventually maybe evaluate a rewrite of the thing that you're inheriting. So first thing, learn how the users are consuming your software. Again, going back to what I said before, many times you write software and you're expecting your users to use it in a very specific way, but it turns out that they're using it in a completely different way. Now, that doesn't necessarily speak bad about the software itself. It just speaks about the needs of the users, right? So sometimes you want to adapt those needs and say, all right, that's probably the direction that we want to go down to, right? Or we're probably spending some time doing some other stuff that is making our users believe that that is the actual use case. Now, is that something that we want to support, or is that something that we want to move away from? Right? If the answer is we want to move away from that, then make it clear, make it explicit that that is not a use case that you want to support and you want to do something completely different. The second thing is you got to run the software. Run it, break it, and like experiment what your users, like experience what your users are experiencing. And there's so much value. Like I wish all software out there had like very good documentation. But even if it has documentation, the best way to learn how the thing works and how the whole logic behind the thing is by running it yourself. Because when you run it, you're going to realize a few things. You're going to realize whether, if the software requires some configuration, you're going to realize whether it has same defaults, for instance. If the software requires, configuring the IP address that it has to listen on, or configuring the port that it has to listen on, or configuring the path that it has to write, logs on. If it has good defaults, you're probably going to be able to run the software without even configuring it or changing anything. But like if you just run it and it crashes on you, then there's something that you might want to start fixing, right? So you got to experience what your users are experiencing. You want to have that user experience. Because user experience is key when you're building software. Because as developers, and before I joined Elastic, I used to work at Red Hat, and I worked at Red Hat for 6 years. And like when you work at Red Hat, most of the time, what you're doing actually is just building libraries. You're building software that other people run for you. Like you don't really run the software, right? And as a developer, you end up thinking, these people are probably going to run the software as I run it on my laptop. And like, that is never the case. I was trying to find like a case where like someone actually ran the software the way I wrote it. It's like, that's never the case. they all have their own use cases, right? So you want to have that same experience so that whenever you're making decisions about the software, making decisions about what kind of configuration options you want to expose, what kind of like experience you want the users to have, at least you know what kind of users you have, and you can match a little bit what they have. And again, like just use it, play with it a lot, try to break it. Like if there's a config option that is supposed to be an integer, put there a string. Let's see what happens. Does it crash? Does it silently go on and keeps running? Is that something that you want your users to experience that way? So try to experiment it, try to break it, and learn a lot of how to use it. And leave changes for later. Like don't code anything. So far we haven't written any single line of code. So read the documentation, read the code now. See, like we didn't read the code until now. We tried to run the software because if you read the code before you run the software, then you're going to be biased. Because the moment you read the main function of your program, you're going to be like, this is shit. Like, we shouldn't be running this. And then you're going to be completely biased. And you're going to be like, no, I would have done things differently. I don't like the way these things interact. So run it, be a user before you are the maintainer of the software, because that's going to teach you a lot. Read everything you have. Read the test, if there are tests. Read the documentation, if there's documentation. Read the code, spend some time reading the code. Remember, don't judge how things were done. Try to understand why they were done that way. Spend some extra time. And I know that right now, like so far, probably 90% of you are thinking like, yeah, but we never have enough time. Everyone wants things like done super quickly. But that's not always the case, right? And if that's the case, try to talk to whomever you report to and make sure that you have enough time to actually do a good job. Read everything you have. Spend some time doing research and learning the code base. Because that's going to be the base. That's going to be what you're going to use. That information is what you're going to use eventually to evaluate whether you want to rewrite the whole thing or not. Now, think about if you're joining a community, like an open source community, you're probably not going to rewrite the whole thing. But if you're joining a company, and in the company someone is like, hey, here's the bugs. There's some code in here. We don't really know what it does. We don't have tests for it. We don't have documentation for it. Go learn it and make sure that you meet all our deadlines. And you got to evaluate whether a rewrite is the right thing to do. So there are some questions that I always ask myself whenever I'm like kind of faced with with this kind of situation. And before I go through those, it's important. The first line is important. 90% of the time, you don't need to rewrite the whole thing. But there are some cases where you want. So the first thing is are you familiar with the ecosystem? So if you're a Python person, which I probably figured out you are, if you're a Python person and someone hands off a bunch of Ruby code to you, then you gotta there's nothing bad with, well, I was gonna say there's nothing bad with Ruby, but there's nothing bad with you writing some Ruby, I guess, but you gotta decide how familiar are you with the ecosystem? You're gonna take this thing on. You're gonna spend time writing code for this thing. And you gotta make sure you meet all the deadlines. So how familiar are you with the ecosystem? Is your knowledge about the ecosystem, and by ecosystem I mean the libraries that you're going to use or that are being used for the software, the Ruby environment, the package management, and all that kind of things that you need, like how to write tests, how to write documentation for Ruby applications, et cetera, et cetera. So how familiar are you with the ecosystem? Is your knowledge about this ecosystem enough for you to actually be able to meet all the deadlines and be productive? If the answer is no, then that is one indication that, or absolutely not, I'm going to be super slow, I won't be able to make any progress, then that's probably one indication that you might want to rewrite the whole thing. But don't ask that question in isolation. You got to ask it with all the other ones that I have here. Would a rewrite be faster? Is rewriting, imagine that you're given this very tiny CLI, and they're we need to add these couple of features, but you have no idea how to write in that language, whatever language it is. And there's well, the functionality is pretty clear, it's small. It would be faster for me to just rewrite it in Python. It'll take me one afternoon to rewrite the whole thing and also add the feature that you guys want. Then it's probably one indication that you might want to rewrite it, because unless you really want to learn that other language, it's probably going to take you longer to actually be able to be productive and add the feature that you need to add, or fix the bug that you need to fix. Would a rewrite make it easier to maintain? Maintenance is probably one of the things that I like. It's one of the most important questions that I have here. When you run your software, or when you write software, you always have to think about maintaining the software, right? And it's just like when you deploy applications. Yeah, say you get this like OpenStack or Kubernetes, and you're like, I'm just gonna deploy Kubernetes. Like deploying Kubernetes, like nowadays, it's simple. Now, making a good deployment that is production ready and that's not gonna make you want to kill yourself tomorrow, that's the hard part, right? Because day zero operations are easy. Day one operations are hard. Because then the thing is running, and you gotta make sure that the thing is not gonna wake you up at 3 a.m. in the morning because it just crashed, right? And the same thing you have to do with the software. You build your software, and you gotta think about how you're gonna maintain it, how you're gonna extend it, how you're gonna run it. Now, if you get these bugs with this like suspicious code, and you're told like, extend it and make sure that you can run it and maintain it, then you gotta think like, if I write this thing in the same language that it's written in, is it gonna make it easier for me to maintain it in the future? It's gonna make it easier for everyone in this team to maintain it in the future. And that actually leads me to the next question. And if the answer is no, I mean, if the answer is yes, then you probably want to also consider the right, because you want easy maintenance of all your software. You don't want it for you to be hard to actually do your job eventually. And remember that time that you spend maintaining software, time that you spend like fixing production problems, is time that you're not spending on new features and like on more cool stuff, like things that you actually want to work on. Would a rewrite have a side effect on our users? This is another one, like an important one, and it's correlated to the original thing about know your user base. Go and learn how people are using it, and make sure that you understand what kind of damages or side effects a change on the software is going to have on your users. If you're given this software and they tell you, there's this feature in the software that's called XYZ, we actually want to remove that because we're not using it internally, and then there's a shit ton of users using it, and then you remove it, then you're breaking everyone's environment, and that's not cool. So evaluate what kind of side effects you have on your users. It sounds obvious, but especially when you're given some software that you don't know by heart, it's a common mistake to make. And will all the members of the team be able to contribute? And again, you're given this box with software, with some suspicious code, and then you have to decide whether you want to rewrite it or not in the language that you prefer. You have to decide whether, if you write it, are you going to be the only one that knows how to maintain it? You're going to be the only one that knows the language that it's written on. If the answer is you are the only Python person in this team, and the rest of us are all Ruby people, then you probably don't want to rewrite it. Because in that case, you're the single maintainer for the whole thing. And there's a bus effect. Like if a bus runs you over, then the team is completely screwed. And you don't want that. Well, like you don't want the bus running you over, but that's a different thing. But yeah, I mean, like you don't want to be the only one that knows how to maintain the code. Like you want your team to be able to support you. So unless the team knows the same ecosystem and languages that you do, you're probably the one that has to learn the new language and join the team, which is always exciting. It's exciting to learn new languages. Anyway, third step, build your guarantees, first refactor, or implement next. So if there are no guidelines, write them. This solves many problems. Coding styles, the way you name functions, the way you write tests, all the expectations that you have from people writing code for this software, write them down. Put them on paper, put it on a website, I don't know, you figure it out, but make sure that everyone reads it in the team. Because whenever you're going to review code, and I hope you do review code, whenever you're going to review code, it's going to make it easier. Like if something doesn't follow the guidelines, you're going to just like go read the guidelines. Like be compliant with the guidelines. It solves it saves you so much time to have these guidelines. If someone doesn't agree with the guidelines can be updated. They're not written on stone. They evolve, right? But you can invite people to actually help you build these guidelines and expand your software and like make it like make your ecosystem better, basically, or healthier. Document everything, usability, APIs, environment. We tend to document only usability and APIs, but we always forget to document how we run the software. And then you're the only one that knows how to run it, and someone else, and the software crashes, and you're on holidays, and no one else on your team knows how to run it. So they have to call you and bother you during your vacation to actually explain them how to run the software. So save yourself this horrible scenario and write the documentation on how to run your software. Make sure you document everything. If you have programmatic APIs, like functions that are public in your software and that you're expecting people to use, document those. Make sure that you document how people are supposed to be running everything. And of course, like all existing tests must pass. write them in if they don't exist. I'm not going to even spend too much time on this one. It's kind of like self-explanatory, I guess. And now, like, we're at the fourth step. You can start writing code. One small change at a time. If you are rewriting something, if you are refactoring some code, don't try to, like, if you're fixing a bug, fix the bug. Don't refactor the code. Then if you want to refactor the code, have your change to refactoring the code later on. Separate patch. You don't have to merge everything in the single PR, right? So make sure that every PR has a very focused and a very specific goal. And it doesn't only make it easier from a review perspective, but it also makes it less dangerous. Because remember, you're new to this code base. You're starting to make changes to it. If you do a bunch of rewrites, you might be changing something that you don't know that some other part of the software actually needs. If you isolate the changes that you're making, then it's going to be easier for you to actually figure out when something breaks. It's like, aha, it broke when I did this change, so there's probably something here. Now, if you fix a bug and then you refactor the whole thing in the same change, you're not freaking idea what's happening, right? So you have to revert the whole thing, then split it and break it down, and it's like, nightmare. All right, focus on progress, not perfection. Super important, super hard to do. Because we like to call ourselves perfectionists, except that none of us is or are. So make sure that you focus on making progress. You have this piece of software again, like you were given this suspicious, like this box with suspicious code in it, and you have to make progress. You gotta meet all the deadlines. You gotta make sure that things are happening here, right? So one small change at a time, make sure those changes land, make sure the software is evolving as you wish or is following the goals in a very progressive way without having to make the software perfect from day one, right? You were given this box, you have your path to perfection, make it a path. Don't try to make it all in a single day and then just like walk away like Rambo and pretend that everything is fine. Don't change functionality during a refactor. I just said this. Like if you're refactoring some code, say you are given this Python 2.3 code base, and they tell you, well, you gotta port it to 3.0. All right, do it, do the refactor, use all the like 3.8 features that you want to use, but do not change the functionality. If the function is supposed to take an integer and return an integer, it has to do the same thing. It doesn't matter how you wrote it in between. Just make sure the functionality stays the same, because that way, again, you can isolate the changes that you're making, and whenever time comes to actually change the functionality and like make it evolve, then you can isolate that change as well after you did all the syntax refactoring that you wanted to do. And once you get to the fifth point, then you got to repeat it all over again, right? You do one small change, then you go back, you take the next feature that needs to be implemented, you go read, make sure that there's documentation, make sure that there are tests. Remember, tests are your source of truth. It is extremely important for you to have a source of truth. If there are no tests, it's probably documentation. If there are no tests and no documentation, there's the human that wrote this thing. But find your source of truth. Find someone or something that will tell you this is the way that things are supposed to work, because that is what you're going to use as a reference to do all the changes that you have to do, right? So once the documentation is there, if there are no tests, write them. Make sure that you have tests so that they can become your source of truth. And I'm not like pitching here like TDD and like test-driven development and blah, blah, blah. No, like that is important, but that is a different thing. What I'm pitching here is that you have to have a source of truth, whatever that source of truth is. If there are no tests, find documentation. If there's no documentation, find a human that knows how the thing runs so that you can blame them after. So as a final note, I think, is there's this analogy of not taking the shortest path, but aim for the fastest, even if it is longer than a short one. So the analogy goes, if you're in a city and you're in point A and you have to go to point B, probably the shortest path is just to cut downtown and go straight to point B, right? You go from north to south, you cut through the city, drive through downtown, but that is the shortest path, but that doesn't necessarily is the fastest one, right? But it turns out like if you go to the left and you go around the city, you're gonna be driving for like an extra 20 miles, but it's actually faster because you can hit the highway and then hit the gas and then you get to point B way faster, right? So the whole point here is that it can be really tempting when you're given these bugs with suspicious code, just like to be like, I don't know what this shit is, and as I throw it in the back, and so I rewrite the whole thing without actually taking the time to go through it and learn it and try to understand your users and like spending time doing all these things. that sound tedious and boring, and they are. I swear to God, they are. But once you do them, then you know the software. And I'm on top of my shit because I'm done. Then you know the software. And you know exactly what needs to happen. And if you're aiming to stay, like to stick around that software for longer, it's all gonna pay off in the future. Because then eventually, you just know the software. You're a good maintainer. Like you know what the goals are. You know where you're headed. You know what needs to change, right? Instead of like taking the shortest path, which is, we need to fix this bug. And you're like, well, I don't know how this thing worked, but I think the bug is here. And then you just like patch it somehow. And it just magically starts working, but you still don't know the rest of the software, right? You don't know the state of the whole thing. Anyway, highlights, so I can give you back your life and go to lunch. Understand the what, the why, and the how. Super important. And remember, do not judge the how until you understand the why. Build your guarantees before changing the software. It takes a lot of like strength to actually not write any code for such a long time, but it pays off in the future or in the long run. Focus on progress, not perfection. Again, small patches, isolated things, make small changes, and make sure that you are making progress. Don't try to make it perfect from the get-go. Know the consumers. Sounds obvious again. If you don't know the consumers, find someone that actually knows the user base. Like if you're joining a company, a big enough company, they probably have like a project management. And like this PM knows the user base because they talk to our users, like our customers every time. Like talk to your support team if you have a support team. But it's like try to get information about your users and document everything. The architecture, the API, how to deploy the damn thing is extremely important. Thank you very much.